Hello and welcome back. We're pretty close to having this motor fully apart. We're to the point now where we need to just push the wrist pins out. I have the C-clips out on the outer side, so we should just go in from the opposing side now and push them out. I'll show you what I mean here. The wrist pin that we're going to push out is right in there, but we got to push it out from the other side. So I have this rod here, and it's pushed against the other end of this wrist pin, and so I'm just going to take the hammer there and then just tap it out. All right, here we go. Now have the wrist pins pushed out for cylinder 1 and 2. So now if you rotate the motor, the rod should just push the piston out. I'll try to illustrate now the technique for getting the pistons out. Once we have the wrist pins out on all 4 cylinders, which we do now, when we turn the crank, you'll see that the piston will start to come out. The rod still makes contact with it and then pushes it out. However, it only goes so far, about there, and that's about it. And I pulled on the pistons to kind of show you why this is the case. Right here, the connecting rod normally goes right in here, and we've pulled the pin out, right? So the connecting rod still is going in between here. And so what we need to do is turn the piston just a little bit so the connecting rod pushes on either one of these 2 sides, and it'll push the piston all the way out. So I'll show you the technique for that. And so now that we got the piston out towards the side, we can rotate the crank back in. And then as we push, we twist, and then we can pull it back out and then just do the same thing. So we kind of get it like a 45-degree angle. There we go. You can see it's getting like 45. Okay, now the rod should hit the different part of the piston, and we should be able to force it out completely. And there we are. And we pull it out. Now when you pull these out, be sure to label which cylinder that they come out of. And also note the orientation. Well, it's difficult to see here, but there will be a dot on one side of this piston. The dot is what faces the front of the motor. There should be one right here. Let me scrape it off so I can show what I'm talking about. All right, I was finally able to scrape enough of the carbon away, but you can see right here a couple of dots. That goes to the front of the motor. So again, just a reminder to label what cylinder that the piston comes out of. Once you get one piston out, be sure to put a rag or something around the connecting rod of the other, so while you're pulling the other pistons, that the rod's not rubbing up and down the inside of the cylinder wall. Okay, now that we have the piston out, I just wanted to show you, this is cylinder number 2 here, which is where we suspected the problem with the rod bearing. So let's just check for play now. Tons of play there. You can hear that. That's definitely the problem. You should not hear any noise at all. That's your rod knock right there. All right, in order to split this block in half, we have to undo a number of bolts, and I believe there's 17 of them. I'll show you where they're all located. Let's count them here. We got 1, 2, 3, 4, 5, 6, 7, 8. And then here on the left side of the motor, 9, 10, and then over on the passenger side, 11, 12, 13, 14, 15, 16, and the 17th bolt, which is located in the very back here, right there. So loosen those 17 bolts, and then we should be able to pull the motor apart. All right, I almost forgot about this little bolt on the bottom side of the motor where the oil pan goes. So there's not 17 bolts that hold this block together, there's 18. This is just a little tiny 10 mm. I've already went ahead and cracked them all loose, so I can just run them out quickly with this. These are all 12 mm, by the way. The ones that are buried in here into the block, those are a 12 point. So I use this type of head. Now we're on the right side of the motor. Also, another thing to show you here, these bolts, even though they're equal in length, are not all the same. The ones on the exterior here just have a single regular washer. The ones that are inside the block here, they go through the water jacket, and they have a different type of washer here. You'll see that it's got a little rubber seal there. It's very important that when you put this back together that you probably should get new washers so they seal well. But the ones that go in here and then on the other side do require that washer. Otherwise, you're gonna have some coolant leakage inside the motor, which would be very bad. And the last one, in order to get this one, I need to use a real small ratchet. This is just a 1/4 inch drive, but it fits in there, whereas the 3/8 just won't do it. All right, here's a quick look at all the bolts that came out, the block that hold it together. 6 of the bolts here are the ones that require the special rubber washers. Those go through the water jacket. Then there's 2 exterior ones, and then the other. All right, now to separate the block, I find it easiest to use 2 pry bars right here on this side of the motor. Start prying apart. Then once you have it apart a little bit, stick something in here to hold it apart, and then just kind of keep working your way around the motor. You do want to be real careful where you do pry though. Pry in places like this, not anywhere where the engine has to seal oil. So be real careful with that. All right, once you have the seal broken all the way around, then it's, I think, easiest to set it up on an end like this, and then just lift the top half off. Come on. I guess this is more of a 2-person job. Okay. There we go. Now we got the block split in half, and here's our number 2. And you can see plenty of play in there. That's definitely our problem. Now we can remove the crankshaft from the motor. Let's pull off this rear main seal, and then it should just lift out. There we go. Now that the crank's out, we can just quickly check the other bearing, see if there's any play. There's number 1, no problem. There's number 2, you can see that has quite a bit of play in it. Number 3, looks good. And 4 looks good. So yeah, let's go ahead and pull the bearing cap off this and take a look at the actual bearing. Let's break these bolts off. Just break these loose first, then we'll zip it off with the impact. Pull the bearings off of here. Here we go. Well, this is looks promising. It looks like most of the damage occurred just being mainly to the bearings. There's no place where it completely wore through, but it's definitely flattened out here. So the good news is there's likely no damage to the crank itself. However, we'll have to take measurements to make sure that everything is within spec. A couple more things to note here. If you look real close at this journal here, you'll see some scoring there. My hunch is that that's just part of the bearing material that's rubbed off on this. I doubt that this is damaged, but we'll try to polish it up and see how smooth it gets and then take measurements. Also, as you're doing this, be sure to number the rods so you know which position they go into. And also, the orientation does make a difference. It matters whether it's this way or this way. And if you look on each side of this rod, you'll see that little legacy mark there. On the other side, it doesn't exist. This is the side that faces the front of the motor, so like so. And also, don't confuse don't get the bearing caps mixed up either. These are mated, so this cap has to go onto this rod. So kind of keep everything together as you take things apart. And just for an interesting comparison, I went ahead and pulled the rod from number 1. And if you look at the journal here, nice and shiny. This one here is definitely scored, so the bearing definitely spun on there. And then if we actually look at the bearings itself, this one here is from number 1, and this is 2. You'll notice that the bearing that spun is a little bit wider, and if you look at the end here, a little bit narrower. This is a little bit better comparison. You can see the one on the right is definitely wider than the one on the left. So this is number 1, and this is number 2, the spun bearing. All right, I looked up the specs here, and apparently the journals should, for standard size, should measure somewhere between 2.0466 and 2.0472 inches. And we measured a minimum of 2.032, and it looks like the grinding limit here is basically 1/1000th of an inch. So I think we're looking at a new crank. I guess that kind of wraps things up for today. Unfortunately, it looks like it's going to be a little more expensive, needing a new crankshaft, probably a new rod as well, although I haven't measured that yet. So anyway, I'll have to contact the owner, see how he wants to go about this, and we'll get some parts ordered, and we'll start another video series for the rebuild. Till then, see you next time.